Look at this number pattern: 3, 7, 11, 15, and it keeps going. You can probably guess the next is 19. But what if I ask for the 100th term? Counting by hand takes too long, and it's easy to make a mistake. This pattern is called an arithmetic sequence, a list of numbers where the difference between each consecutive term is constant. Instead of adding over and over, we can use a formula that acts as a shortcut. It lets us calculate any value in the sequence based on its position. Using this formula replaces manual counting with a single, direct calculation. In math, we use positional labels. The first number is term 1, written as t subscript 1. The second is term 2. To build our formula, we need a starting point. The first term is 3, represented with the variable a. Next, we look at how the pattern moves forward by checking the gaps between the numbers. From 3 to 7, we add 4. From 7 to 11, we add 4 again. This constant jump is called the common difference. We represent this common difference with the variable d. An arithmetic sequence is defined by these two pieces of information: where it starts and the exact value it adds each time. This is the general formula for any arithmetic sequence. It is written as t subscript n equals a plus n minus 1 times d. Now we substitute our known values. For our specific sequence, we replace a with 3 and d with 4. It's important to see why the formula uses the bracketed n minus 1 instead of just n. If we want to find the very first term, where n is 1, then 1 minus 1 becomes 0. This cancels out the common difference, leaving us with just our starting number, 3. If we used just n, we would accidentally add an extra 4 to the first term. To simplify the formula, we multiply the 4 into the bracket, giving us 3 plus 4n minus 4. Combining the constants, the 3 and the negative 4, we get negative 1. Our final formula is t subscript n equals 4n minus 1. This simplified equation is now specific to our pattern, letting us find any term value by plugging in its position. Let's use it to find the 10th term we mentioned earlier. Since we're looking for the 10th position, our variable n is 10. We replace n in our formula with 10. Finishing the math, 4 times 10 is 40, minus 1 is 39. By substituting the position into the formula, we found the value of the 10th term without having to list the numbers in between. We can also work in reverse. Suppose we need to know which position in this sequence holds the value 79. In this case, 79 is the value, not the position, so we replace t subscript n with 79. We are solving for position, so the variable n stays in the equation. To isolate n, we first add 1 to both sides. That gives us 80 equals 4n. Finally, we divide by 4. 80 divided by 4 is 20, which tells us that the 20th term in our sequence is 79. This linear algebra allows us to find the exact location of any value within the pattern. To solve any arithmetic sequence problem, start by identifying the first term, a, and the common difference, d. You then substitute those values into the general formula, keeping that n minus 1 in place so the math remains accurate for the very first term. Once you have your sequence-specific formula, finding any term is just a matter of algebraic substitution. Now that we can find individual terms, we can move on to finding the total sum of all numbers in a sequence. With these steps, you can now navigate any arithmetic sequence problem. We'll tackle finding that total sum in the next lesson. See you then.